As we go through the evolution of intraocular lenses and discuss first monofocal, then astigmatic lenses, and then of course presbyopia correcting lenses that are either refractive or diffractive or sometimes a combination of the both, we obviously have learned a great deal. One of the problems that we learned about was all of the visual disturbances that patients could have with some of those technologies. And so there was this quest to really go beyond, to deliver range of vision, but at the same time really minimize as best we could any of the visual disturbances that we're seeing, especially with certain types of lenses and certain geometries of the lenses and certain optics that we have. And this takes us really into the whole realm of the extended depth of focus lenses, EDOF lenses. And Rob, maybe you can give us a little background and a little history of how that came about and what the actual goals were for that, and how is it different, really, than what we've had in the past.
When you think about adding range of vision on top of a monofocal IOL, I think what's fundamentally important is we have to be talking about a meaningful range of vision. And I think the diffractive multifocal IOLs definitely deliver on that ask of giving a meaningful increase in range of vision. But as those lenses became more prevalent and we started to get more experience in the real world, we realized, as you suggested, Steve, that there are some patients for whom that may not be the most appropriate choice. And in some ways, it's fundamentally driven by the optical design choice. So again, the first thing we had to challenge ourselves with was how do we still deliver a meaningful increase in range of vision, but at the same time make a lens that complements the current technologies. And that's what led us to non-diffractive approaches where again, we're able to reach patients that may not be reachable with the previous technologies. And at the same time, the range of vision is not the same as the multifocal IOLs, but it's still a very meaningful increase in range of vision compared to monofocal IOLs.
And it's that trade-off, right? So before we were with diffractive technologies, we were really trying to maximize near and range of vision, but the trade-off was that they might have some visual disturbances and splitting of light, which for certain pathologies, we're really not comfortable putting that in patients. We know they're going to have a higher incidence of visual disturbances because of their own pathology. And so if we can take those patients and still give them something that increases, as you said, meaningfully their range of vision without that particular trade-off, then that expands the number of patients who can take advantage of that kind of technology.
I mean, the other interesting aspect is there is the whole question of clinical suitability of a given technology for a given patient, but also it's become increasingly important to understand non-clinical questions about a patient's preferences, a patient's lifestyle, et cetera. And I think that's where the EDOF technologies are also very complementary to the multifocal technologies in terms of giving very good intermediate vision for patients for whom that may be the most important.
Right. Yeah.
The other part of this, to me as well, is consistency.
I think the other thing it opened up is not just more patients to receive the technology, but more surgeons who felt comfortable offering advanced technology to their patients, because so many of us early, especially with the early forms of these lenses, had patients who sometimes were not the right patient, and they had that trade-off that they were not able to tolerate with visual disturbances. And some surgeons may have kind of backed away from offering those kinds of advanced technologies. But now we can, in a way that, at least for that particular trade-off, we don't have to have those conversations. It might have been difficult in the past.
Yeah. So Rob, how did we come up with that design for the EDOF lens? I mean, it was obviously very innovative, but very untried. I mean, there wasn't anything else in optics that necessarily was utilizing, this very much. And all of a sudden, we're going to put this into an intraocular lens?
What we always start with is a clear definition of the goal, what we're trying to achieve, right? And here it was very clear. We wanted a meaningful range of vision. We wanted to do that without the introduction of side effects. And again, all we could really point to in the IOL space were technologies that we knew wouldn't meet that ask. So we actually looked outside of ophthalmology. We found a technology in wavefront shaping that does have some precedent in certain laser applications and other areas. And we assessed the potential suitability of that on an IOL platform against those criteria. Can we deliver this meaningful range of vision, and can we do it in a way that doesn't bring undesired side effects? It wasn't as easy as copying and pasting something that already existed somewhere else, but we had the genesis of an idea, the genesis of an approach, and through lots of iteration, lots of insights from customers, we iterated it and refined it until we got to something that we think checks the boxes pretty well.